filling in the blank here. When we have an algebraic expression that defines a function, we already know what a function is. Somebody remind us, what is the definition of a function? How did we decide if we have a function or not? Somebody give me a definition of a function, John.
If each x value has its own y value.
Okay, so if each x value has only one y value, then it's a function. Okay, so if we have an algebraic expression that defines a function, we call that a function rule. So when you're asked to write a function rule, you're really being asked to write an algebraic expression. Should have learned in going through lesson 3.3 on your own that the input of a function is called the independent variable. The input, so the one that gets put into the function rule. So the independent variable so the input of the function is the independent variable and is used in the function rule. So oftentimes it's x. If it's x and it's y, it will be the x. If it's a and it's b, it might be a. If it's m and it's n, it probably would be m. So the independent variable, and typically it is x. The output of the function is the dependent variable. So what you get, what comes out of the function rule, the output of it is the dependent variable, and that is set equal to the function rule. And it's often the y. So if we have x's and y's, the y is the dependent variable, it's the output of the function, it's what the function rule is set equal to. And then a method of writing functions that is commonly used is our second learning objective, function notation. When they ask you to write the function, the equation in function notation, you got to know what they're asking you to do. So the function rule, instead of being set equal to y, it's set equal to f of x. So f of x, that's how you say it, f of x instead of y. So you'll have f of x equals a function rule that has an x involved in it. So you won't see a y in the equation. But you have to start putting together up here, f of x means the same thing as y. F of x replaces y. They mean the same thing, okay? So let's start by learning how to write an equation for a function. First thing we're going to have to do is we're going to have to decide what would be the function rule. So right here, we're going to, when it says if you, we're going to determine the function rule. So what's happening in that table? Remember, x is the input. We put something in for x, and it outputs the y. So what's happening in that table of values with those x's and those y's?
Y is equal to x plus 3.
So every time you add 3 to x, do you get the y value that is associated with it?
Yeah.
So 1 plus 3 is 4, 2 plus 3 is 5. It works all the way across the table. So if you add x, add 3 to x, you get y. If you add 3 to x, you get y. So we're going to say our function rule, we're going to put it up here, our function rule is really x plus 3. Add 3 to the x value, that's the function rule. You will get the y that you're going to set it equal to. So our equation would be y equals x plus 3. We set our function rule equal to y. Okay, well, if they ask us to write it in function notation, how would we write it? If they say, write the equation for this function in function notation. John?
F of x is equal to x plus 3.
Yeah, the f of x just replaces the y. F of x just takes the place of y. F of x means y, means the same thing. Just another name of it. So here's what f of x is really saying. You have a function where x is the independent variable, it is the input, and when you use the function rule on the other side, you will get the function evaluated at that x value. You will get the y value for that function. So it's really just saying it, talking it in function language, okay? Okay, let's look at this. Instead of it being in a table, now it is given to us as a set of ordered pairs in their ordered pair notation. So what looks like the function rule this time? I think it's going on this time. What do you have to do to x to get y? And it has to work for all 4 ordered pairs. By the way, now you can do more than one operation. It doesn't always have to be adding. There can be, we have 4 operations. What do you think's going on here? Try something. Riley? You don't know. Sage?
The x, y, no, never mind.
Let's multiply x by something. Yeah. Pick a number to multiply x by. And then let's, Sage,
x2 minus 1.
x multiplied by 2,
Yeah,
so 2x.
yeah, 2x minus.
So if you multiply the x value by 2 and subtract 1, does it work every time?
Yeah.
So 2 times 1 is 2, take away 1 is 1. 2 times 2, take away, what is what? 4, take away 1 is 3. 2 times 3, take away 1 is 5. 2 times 4, 8, take away 1 is 7. So if you multiply x by 2 and, let's see, I think I'll really need a comma there, and subtract 1, there's where my comma is, you get y. So our function rule this time, let's put that up here, function rule is, how would we write that as an algebraic expression? We just wrote it in words. How would we write our function rule as an algebraic expression? Riley?
2x minus 1.
Yeah, 2x subtract 1. 2x take away 1. So when we write our equation, we say you get the y by using this function rule. So y equals 2x minus 1. Okay, go ahead and write that in function notation. If they ask you to write it in function notation, what you're going to have to pay attention to for the problems, either it'll do in a set of directions above a group of problems or within the problem itself that will ask you to give it in function notation. We would write it f of x equals 2x minus 1. Or in other words, whatever value you put in there for x, you multiply it by 2, subtract 1, you will have the function evaluated at that. That's what your y value would be. You have to do this in your homework. You don't get to give up on it. You have to try things. You might have to multiply by something and add something. You might have to divide. You might have to add only. You might have to subtract only. But sometimes you might only have to do one thing in your function rule, one operation. Other times there might be a couple of operations that go on. So anybody have any questions about that? Okay, then let's go on to identifying independent and dependent variables. So here's our situation. We have the doctor needs to know your weight before determining the amount of medication. We're not going to write any equation for this or anything. We have no numbers here to work with. We're just trying to decide which is the independent variable in this situation and what's the dependent. So in other words, what's controlling the situation and what's dependent upon that control, okay? So, Tyler, what's the independent? Your weight. In other words, if the doctor knows your weight, then what is the result of that? How much medication to give you, so amount of medication. So your weight is the independent, and how much medication you're going to get is dependent upon how much you weigh. A smaller person does not take as much of the same medicine as a larger person does. Okay? Okay. Number 2. A company charges $10 per hour to rent a jackhammer. What's the independent variable in this? What's controlling? Sage?
Hours.
Hours, okay, so the number of hours that you actually rent, hours renting, how many hours you rent it for, what's the dependent variable then?
Cost.
Okay, dollars what though?
Price.
Price what though?
Cost per hour.
Not cost per hour, we know how much it costs per hour, how much is it per hour?
Using the jack.
Okay, so it's the total cost, isn't it?
Yeah.
According to how many hours you rent the jackhammer, it tells you the total cost. So we have to make sure that we don't just say dollars and it's not dollars per hour. We know it's $10 per hour. According to how many hours you rent it at $10 an hour, what would the function rule be in this one? What would the function rule be for this one?
10x.
10x. Take 10 times the number of hours, that's the function rule, and you will get your y, the total cost, the dependent. Okay, now we're going to do both things. We're going to identify the independent and dependent, and then we're going to write an equation in function notation for the situation. So we have a math tutor that charges $35 per hour. Okay, what's the independent variable in this one? In other words, what's the x going to represent in this situation?
Number of hours tutored.
Yeah, number of hours tutored. You get to pick how many hours you want to be tutored. And then what's dependent upon how many hours you are tutored?
Total cost.
Total cost again. So how much you're going to have to pay in total is dependent upon how many hours you are tutored. Okay, so what's the function rule this time? What's the function rule? Riley, what do you think? 35x. And y is our dependent variable, so we would set it equal to y, but they want it in function notation, so instead of setting it equal to y, what are we going to set it equal to? F of x.
They want the equation.
They want the equation, that's function notation. This is still going to be an equation. It's going to have an equal sign in it. Instead of y equals, we're going to say f of x equals 35x. You will get how much it costs, f of x, same as y. You will get how much it's going to cost you total by putting in how many hours you're going to pay this math tutor, $35 an hour. Okay, you go ahead and do the next one on your own, number 4. So figure out what's going to be the independent variable, what's dependent upon that, what's your function rule, and write it in function notation, your equation. And then if you're done, while you're waiting, you can see if you can answer that bottom question. Think about that one and see if you think you're going to be able to come up with the answer. What's the independent variable number 4? Sage?
Months.
Number of months. Okay, number of months. And let's say it like that, number of months. Okay, what's the dependent variable then?
Total price.
Total cost again, total price. Lots of times in these real life situations, because that's what life is about, spending money, it seems like, it turns out to be total cost, but not always, okay? Okay, what's the function rule? That's all I want you to give me right now. What is the function rule for this one? I want us to be able to talk in that language.
40x plus
Yes.
40x plus 100, anyone agree with that? 40x plus 100 is the function rule.
100.
That's for the first month.
That's
Yeah,
for, is that only for the first month?
No.
Well, that's really
Yeah,
good.
for all of them.
When is it for the first month, when you put? When is it for the first month?
140.
When you put 1 in for x, right?
140.
If you want to know how much it's going to cost you for 6 months, you put 6 into the function rule of x, and you would evaluate. So, and then since they want it in function notation, we'll set it equal to f of x. So our function rule, 40x plus 100. $40 every month, x representing how many months you're going to be going there, plus the 100, the one-time membership fee. You only want to pay that once. Okay, how many of you were successful on your own with that one? Okay. Does f of x represent the domain or the range?
Range.
Why?
Because that's one.
Because it's y.
Right.
Yeah. F of x is the same as y, and we know that the y values make up the range, right? So it's the range. So when they ask you, if you're given an equation in function notation, and they ask you to give the range, you need to give what f of x values would you get when you're evaluating. So the domain is always the x values, the range is always the y values. Even though there's an x in this, that does not mean this is just x. This means the function evaluated at x, and that gives you actually your y value. Okay. So anybody have any questions on what we've done so far? This is the part that will be, challenge you probably the most in the homework. Determining those function rules, determining what's the independent variable in the situation, what is the dependent variable in the situation. Okay, then let's go on to the last thing we're going to do, which is evaluating functions. So some of you should have already done this because you did your SQ3R, and we'll do it again. Okay? We'll do it in here and we'll see how successful you were in your own SQ3Rs. So, those of you who haven't done the SQ3R, that does not let you off the hook for doing these again in your own class. Okay? So, we have h of c. Notice instead of being f of x this time, it's h of c. So that means the independent variable instead of being x this time is what? C. Instead of using x, they're using c for the independent variable. And our h of c is our y value, really, isn't it? Okay? So, h of c equals 2c minus 1. What's that 2c minus 1 called? The function rule. 2c minus 1 is the function rule this time. And we're supposed to evaluate it for when c is positive 1 and for when c is negative 3. So we have two separate problems to do here. So we're going to do h of c equals 2, and we'll substitute 1 in for the c value. Then we'll subtract 1. So we're going to get h of c is equal to 2 take away 1, because we do the multiplication first, and then the subtraction. And our h of c, our dependent value, when our independent value is 1, is what? 1 also. So in reality here, what we have is an ordered pair for the graph. What is the ordered pair for this one? 1. No, ordered pair has to have 2 values. What's the ordered pair in this situation? Riley? No. in an ordered pair, okay, now maybe we need to think of it this way. We've only been thinking of ordered pairs as x, y, right? X and y. Okay, so x is the independent variable, y is the dependent variable. So we have the independent variable listed first, followed by the dependent variable that you get as a result of that independent variable. So what's our x value this time?
C.
C. And what was our C value we used?
1.
1. And what did we get when we put 1 in for C? What was our output?
1.
1. So what's our ordered pair? 1, 1. Let's write that. We really have ordered pair 1, 1 here. You need to understand what you're finding. You were finding the dependent value, the y value for an ordered pair. Okay, now let's do it with -3. 2 times -3, and then take away the 1. So we have h of c equals, what's 2 times -3? -6. So we have -6 take away 1. So our dependent, our output this time is what? -7. So what's our ordered pair this time?
-3, -7.
-3, -7. So let's check that function rule out. The function rule is 2c minus 1. In other words, take the independent value times 2, then subtract 1 from it, and you'll get your, so 1 doubled is 2. 2 take away 1 is 1. -3 doubled is -6. Take away 1 is -7. So just like how we were taking them from ordered pairs and working backwards, getting the function rule, the same thing, if we know the function rule, we better get the right x and y values that should be paired up together. Okay, so anybody have any questions about that? Okay, then let's do the next one. G of t equals 1/4 t plus 1. What's our function rule this time? 1/4 t plus 1. What's our independent variable this time? Instead of being called x, what's it called? T. And our y value is g of t. Or in other words, even though they're not f's, they're still, they don't always use f in function notation. Like in the last one they used h, and this one they're using g. It's still function notation. So we are going to do when t is -24. So let's go ahead and substitute. And basically, here's what I should have been writing in the last one, and I did not. We should put g of -24, or in other words, the function evaluated for -24. Replace the t even here with -24. The function evaluated at -24 is 1/4 of that plus 1. 1/4 of that -24 plus 1. Okay, so basically what we're doing is we're taking a positive 1/4 times a negative. First of all, what's that? A positive or a negative? A negative. And what's 1/4 of 24? 6. So we have -6 plus 1. So g of -24, we're getting closer. G of -24 is what? -5. So what ordered pair do we have this time? -24, our independent variable. The output, -5, the dependent. So -5 was dependent upon what happened when you put -24 in for t, the input. Okay, go ahead and do the evaluate t at 400 and give your final answer as an ordered pair again. Remember, we're going to write it, I didn't do it last time, but we're going to do this all the time. We're going to get used to this. G of 400 equals 1/4 times 400 plus that 1. So Noah, what's our ordered pair this time? Zach.
400 and 100.
Yeah, 400, 101. This would have been a tricky function rule to have to figure out, wouldn't it have been? Looking at those two ordered pairs, trying to figure out what got done to X to get the Y. That would have been a tricky one to do on your own. What is the function rule this time? It basically is divide the X by 4. Isn't multiplying by 1/4 the same as dividing by 4?
Yep.
Divide the X value, in this case the T value, by 4 and add 1 and you will get your Y value. Or your, in this case, G of T. Okay, let's go to the middle of page 182. Middle of page 182, doing the check it out that went with your number 5 objective in this lesson. The settings on a space heater are whole numbers from 0 to 3. The total number of watts used for each setting is 500 times the setting number. Write a function to describe the number of watts used for a setting and find the reasonable domain and range for the function. Okay? Now, what did it say we have to do to get, what's our independent variable in this one first of all? Let's just write that. What is independent this time? What's controlling the situation?
The knob
The knob? Okay, what about the knob?
that has 1, 2, 3, or 0 to
And so that's called the setting number, right? Okay, so the independent is the setting number. And the dependent, what is dependent upon what setting number you use?
Watts.
Okay, total number of watts. How much heat is it going to kick out? Total is an important word there. Total number of watts. Okay, what's the function rule this time? Let's write it. Function rule. We're even practicing everything we had to do here. Function rule is just the function rule. Remember, that's an expression. There's no equal sign. It's not an equation. What's the function rule for this one? We'll use X and Y. Aaron?
X times 500.
Yeah, X times 500. So, or in other words, we could say 500. Well, you know what? We'll do it the way you said it right there. The function rule is X times 500. You have to multiply the setting number by 500 because each setting number is 500 watts, right? Isn't that what it said? Okay, so now our equation that they want, and they want it in function notation, our equation would be what then? Instead of equal to y, but instead of having
F of
y,
X is equal to 500x.
yeah, f of x, the y value is equal to, and this is how you would see it written algebraically, 500x. That means multiply x and 500 times each other. Okay, then they want a reasonable domain and a reasonable range. In other words, give the domain for this situation. What is the domain? Well, the domain is made up of the x values, which is the independent, which is the setting number. So what's going to be in our domain?
0
0?
is less than or equal to X.
No.
0, 2, 3.
Yeah, we don't set it at 1.5 or 1 3/4, or it said there were setting numbers 0, 1,
2, 3.
2, 3, and that's all the higher it went, correct? Okay, the range is the output, the y values you get when you use those setting numbers. So what's our first range value?
0.
0. There's no heat coming out when it's set at 0. What's our second range value? 500, or in other words, if you put 1 in for x in our function rule, 500 times 1 is 500. What's our next one?
1,000.
1,000. 500 times 2. And what's our last range value?
1,500.
1,500. Okay. Questions on that one? We kind of practiced a few different things in that. Okay.